This lesson is an extension of Chapter 7. To extend the use of trigonometric ratios to acute and obtuse triangles using what is known as the law of sines and the law of cosines. In the last section, we learned to use trigonometric ratios, sine, cosine, and tangent to solve right triangles. In fact, we have said in the past that these really only apply to right triangles. In this section, though, we're going to apply two key ideas which allow us to solve both acute and obtuse triangles using these ratios. It's beyond the scope of this class really to show you where these ideas came from, even though what it does is apply some right triangles by dropping down the altitudes. But anyway, you'll see that in a formal trig class. But these ideas can be really helpful in solving triangles. The law of sines. If I have triangle ABC with side lengths A, B, and C as shown, now notice what this says is that for angle A, its opposite side, we represent its length with a lowercase a, and for angle B, we will represent the length of its opposite side with a lowercase b, and for angle C, we will do the same thing, represent the length of its opposite side with a lowercase c. Now what the law of sines says is that the relationship between the sine of A and the length of A will be the same as the relationship between the sine of B and the length of B and the sine of C and the length of C. That's why it's called the law of sines. So let's look at the law of sines to solve this triangle. Okay, the first thing I want to do is find the other angle, because remember, to solve a triangle means to find all angles and all sides. So first I'll find the measure of angle C. We know that the whole thing is 180 degrees, so I can find that measure of angle C is 34 degrees. Now I could use angle B or angle C, it doesn't really matter, but what I want to find now is the length of side A. So I'm going to use the law of sines to find the length of side A. What I know is that the sine of angle A, so the sine of 81 degrees, is to angle A as the sine of, let's say, angle C, 34 degrees, is to the length of C, which is 15. So I have the sine of 81 is to A is the sine of 34 is to 15. So A then becomes 15 times the sine of 81 divided by 34 when we solve our proportion, and we find out that that is approximately 26. Now I need to find B. Now I could use angle A and side A, but since that's really an approximation, that's probably not the best thing to do. Once again, I'll use angle C and 15 because I have the exact measurements there. So to find B, I'm going to do the sine of 65 is to B as the sine of 34 is to 15. And so B is 15 times the sine of 65 divided by the sine of 34. I simply cross multiply and divide and find out that B is approximately 24. So now I have solved that triangle. I have all three angles and all three sides. Now, the law of cosines. Law of cosines at first may look a little bit more complicated, but I think once you see the pattern, it is not that bad. Using the same setup as before, where side A is opposite of angle A, lowercase b is the length of the side opposite angle B, and lowercase c is the length of the side opposite angle C. What the law of cosines says is that A squared is going to always equal B squared plus C squared minus 2 times B multiplied times C times the cosine of A. Now I know that looks fairly complicated, but once again, you really only have to learn one of these, even though we're going to do 3 of them, because the pattern is so similar. Notice this is sort of involved with Pythagorean theorem. B squared will always equal A squared plus C squared minus 2 times AC times the cosine of B. And C squared is A squared plus B squared minus 2AB times the cosine of C. So notice this pattern follows where when I'm looking for A, I'm going to, the square of it is equal to the sum of the squares of the other two sides minus twice their product times the cosine of the angle across from the side I'm looking for. So for B, I'm going to have a squared plus c squared. I'm going to subtract twice a times c and then multiply it times the cosine of B. And same thing goes with C. So let's look at this. Use the law of cosines to solve this triangle. So to use my law of cosines, I'm going to find F first. Now, if this was a right triangle, I could use Pythagorean theorem, but we don't know that it's a right triangle. It's not marked. So I'm going to use the law of cosines. Remember, to find F, I want to square the other two sides minus 2 times the 2 multiplied together times the cosine of the angle opposite of F. So in this case, I'm going to have 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 46 degrees. That would tell me that F squared is approximately 75, so then I could take its square root and get approximately 8.7. Now to find the measure of angle D using here, I don't want to use things that I'm not sure about, so let's get the measure of angle D by using my inverse trig. I have the opposite and the hypotenuse. Opposite and hypotenuse is sine, so I will use the inverse of sine equal to 9 over 12 and get that that's approximately 48. So I've got that this is about 48 degrees. I've got this is about 8.7. So the only thing I'm missing is angle E, and I can get that by subtracting. I find out that angle E is 86. So now I have all angles and all sides, and I have solved this triangle.